Hello everyone and thank you for attending this talk. My name is Reza Abbasi and I'm excited to present our paper titled Clip Under the Microscope, a fine-grained analysis of multi-object representation. This is a joint work with my colleagues from Sharif University of Technology. In this work, we perform a deep analysis of Clip's limitation in multi-object scenario. While Clip has shown impressive performance on many tasks, it struggles when multiple objects are present in an image or a caption. To investigate this, we design a dataset called ComCO and conducts semantic experiments to uncover biases in both image and text encoders of Clip. We further trace the origin of these biases and explore their practical implication in tasks like image-text matching and text-to-image generation. Our first step was to build a new dataset for controlled multi-object analysis. We used Blender to create synthetic scenes containing 2 to 5 ComCO-style objects. This allows us to precisely control object size, position, and combinations, enabling fair comparison across different object configurations. Unlike previous benchmarks, ComCO enables fine-grained evaluation by isolating factors like object order in captions and object size in images. This makes it practically suitable for studying encoder-level biases. Next, we examine bias in Clip image encoder using image-based object retrieval. Given a multi-object image, we retrieve the most similar single-object image. We also ran a similar retrieval experiment on the text encoder called text-based object retrieval. Here, we compare multi-object captions with single-object ones and try to retrieve the most similar single-object caption to multi-object caption. Here we show how Clip's encoder are biased in multi-object scenario. On the left, in TOR experiments, we can see Clip strongly favors to first mention object, retrieve it far more often than the later ones. On the right, in IOR experiments, we can see the image encoder prefers the larger object. In most models, it retrieved with over 80% accuracy, while smaller objects are almost ignored. These results show that Clip overrepresents certain objects based on the order in the text and the size in images, which can hurt performance in complex sense. To understand where these biases come from, we examined the model's attention pattern. For image encoder, we found that the larger objects occupy more visual patches in the vision transformer, which leads the CLS token to attend more of them. This explains the size bias in image representation. To understand why text encoder favored the first mentioned object, we analyzed the LAION dataset. We found that in the most image captions, larger objects tend to be described earlier. This naturally teaches the model to associate earlier tokens with more salient content. We also tracked how this bias evolved during training. On this plot, we show TOR accuracy over training checkpoints. As the model sees more data, the gap between the first and the other objects increases. This suggests that bias is not just inherent from the data, but also amplified by Clip's contrastive training, making earlier tokens dominant text representation over time. We then test how these biases impact downstream tasks. In image-text matching, we create scenarios where the largest or most salient object appear in different positions in the caption. Clip performs better when the larger object is mentioned first and worse when it appears later, confirm the practical consequences of this bias. Similar effects show up in text-to-image generation using models like Stable Diffusion. We observe that changing the order of the objects in the prompt shift which object appear most prominently. This suggests the training time biases in CLIP carry over into generative models built on top of it. In conclusion, our study reveals systematic biases in CLIP's encoder that degrade performance in multi-object scenario. We believe these insights are valuable for further VLM development and dataset design. For more detail, our dataset and analyzed code are publicly available. Thank you for your watching.